Like all of these problems, start by making a drawing to help yourself kind of digest what all's going on in the situation. And if you feel like adding a little bit of character to your drawing, feel free. Kind of helps you see what all's going on in the situation. But I'm just going to focus on the geometry here. So I've got two triangles. They happen to also be right triangles. But the biggest thing is knowing that they are similar triangles. And that's what makes this problem easier to do because we aren't having to build a whole Pythagorean theorem around it. We can get away with actually just doing a couple similar triangles here. Now I'm going to go ahead and start labeling some of the stuff that I know here. So I know my lamp is 5 meters tall, so I'm going to go ahead and label that as 5 meters. And the man is 1.8 meters tall. And he's walking away at 1.2 meters per second. And what we want to know is we want to know how fast is the shadow increasing. So basically, how quickly is that changing? So I want to give that a name. I'm going to call that S for shadow, which means I'm trying to figure out what is ds over dt. All right, I now need to label my other piece here. And remember, this is kind of that critical part about being able to do this particular type of problem, the shadow problems as I call them, is that I'm labeling the shadow with a variable name, and I'm going to label this distance between the lamp and our person also with a variable name. And I'm going to call that d for the distance between them. Now, you might be wondering, why don't we need to give these two variable names? Because in some of the previous problems, I said give everything a variable name and then sort it out at the end. You could, but the reason why I'm not worrying about it here is because one, it would complicate our equation quite a bit, and two, we really only have to give variable names for something when it's something that actually changes. Because the height of the lamp doesn't change and the height of the person doesn't change, they are in fact constants. And so even if I gave them variable names, by the time I went to put in the derivative values, like how quickly they were changing, those would just be zeros anyway. So that's why I'm not worrying about that, in case you're wondering. All right, now that I've got my setup here, I can go ahead and write my equation. So the last time I did one of these for you, I did small triangle over big triangle. There was nothing magical about having to do small over big. You could also do big triangle over small triangle. And so I'm going to do that just for the sake of being different. And you can pick whichever way you like to do it in the future. All right, so the key is that I did big over small. So when I set up the other side of this proportion, I again have to do big over small. So big length is that whole length right there. Notice that's the d plus the s, because d is only taking us from the lamp to the person. So the top here is going to be the d plus the s. The bottom then is small triangle, that length on the small, which is just the s, the shadow length. Now we got our setup. Now that we have this, the rest is just a matter of simplify and find the derivative, which that's the complicated math, but really the hardest part of this problem for you is probably just getting to this point. So let's go ahead and cross multiply and simplify however much we can. So I've simplified it down. If you wanted to solve it for S or D, you could, but I'm just going to go ahead and leave it here. And now I can go ahead and find my derivative with respect to time. Now that I have my derivative, the last step is just a matter of plugging in the value that I know and solving for the value that I don't. Now the value that I know here is the 1.2 meters per second. Now remember, that is how quickly the person is moving away from the lamp. And so that means that it is really this length that's changing right now. So that is actually the dd over dt. Because remember, we're trying to figure out how fast the shadow is changing. So we shouldn't know what the shadow length is changing by just by reading the problem. Otherwise, it'd be a rather silly problem. All right, so take that value and plug it in for the dd over dt there. And then solve for ds over dt. And so after I multiply the 1.8 by 1.2 and then divide it by 3.2, I get 0.675. In your final answer, remember the units. I haven't talked about units in a couple problems, so I want to remind us about how we know what it is. I know what it is because it's going to be the s value over the t value. The ds over dt is telling you about your unit. So ds, that's what the shadow length was measured in. That's meters. dt, that's what time was measured in. time here was measured in seconds, so that's how we know it's going to be 0.675 meters per second.